atomic structure, electrons and protons. Dalton's atomic theory said that atoms were indivisible, the smallest possible piece of matter. We now know that this is not true. What we are going to see in this and the next screencast are some of the historical experiments that led us to understand that atoms are made up of smaller parts. The ability to generate continuous electric current in 1800 led to the use of electricity to decompose compounds into their constituent elements. This process is called electrolysis. A number of elements were discovered using this process, including sodium, calcium, and magnesium. These elements are not found in their pure state in nature. They were only known in compounds. In order to isolate the elements, molten compounds were used, meaning they had to be at extremely high temperatures. In order to melt sodium hydroxide, the compound used to isolate sodium, the temperature has to be 318 degrees Celsius, which is 604 degrees Fahrenheit. The process of electrolysis led chemists to understand that electricity, the movement of charged particles, was somehow related to atoms and molecules. Let's now review some vocabulary related to electricity and electrolysis. An ion is any charged particle, usually a charged atom, but it could be a group of atoms. A cation is a positively charged ion, and an anion is a negatively charged ion. The anode is a positively charged electrode. It attracts anions. The cathode is a negatively charged electrode. It attracts cations. As technology improved, an apparatus called a cathode ray tube was invented in the late 1800s. A cathode ray tube is a glass tube with a vacuum inside, and a cathode and an anode. When a fluorescent screen is placed lengthwise in the tube, if a current is turned on, a beam is visible, moving in the direction from the cathode toward the anode along the tube. This beam is called a cathode ray because it originates at the cathode. When J.J. Thomson used this cathode ray tube, he discovered that a magnetic field would bend the cathode ray, the ray bending away from a negative charge and towards a positive charge. This showed that the cathode ray was made up of negatively charged particles. Thomson called these electrons. Using a similar apparatus, Eugene Goldstein found particles moving in the opposite direction. He used a perforated cathode, which was shifted along the tube so that there was room for particles to move in the other direction. Since these new particles were moving in the opposite direction, emanating from the anode, they were determined to be positive particles. These were named protons. Other experiments that we are not going to go into showed that protons were nearly 2,000 times heavier than electrons.